Hello, all. Welcome back to a new episode of Super Voice 2022, the first reality show in the testing space by Synapse QA. My name is Amala. I'm the host for today. Today, we are going to have the last episode of Knockouts round, and as you know, this round is based on the theme technology in testing. I hope you have watched the previous episodes. If not, please do watch our previous episodes from the links given in the description box. Okay, now I would like to invite our dear judges. So I'll start with welcoming our dear judge, Lena. Lena is a senior leader and technical strategist. She's an international speaker, blogger, and workshop facilitator. Welcome, Lena.
Thank you so much, Amala.
Hi, how are you?
I'm really good. This is like the perfect way to end my week here in Stockholm.
Yes, yeah, that's great. Thank you. And our next judge is Julia. Julia is the head of training and development at Quality Works. She has spoken at over 30 events and was the keynote speaker for Test Automation Homecoming Celebration. Welcome, Julia.
Hi, thanks for having me.
Okay, it's our pleasure. And okay, so I would like to ask you how you feel about being a judge in Supervoice, both of you. So I'll start with Lena.
Um, I was really nervous when you asked me, but I feel I could get used to this. So maybe I should put my name out there for some more reality shows out there.
Okay, so what about you, Julia?
It's been good so far. It's been really interesting to see the different contestants and their thought process, and just to be able to give them some feedback that's going to help them feel good about themselves, but as well help them to improve to be even better. It's really good. So I'm really liking it so far.
Okay, nice. Thank you, judges. So now let's start our Super Voice 2022 episode 5. And in this round, our three contestants will speak on the theme technology in testing. I would like to welcome our first contestant for today, Rahul. Rahul is a software tester and generalist. Currently, he works as a senior software engineer with IFM Engineering in India. Hi, Rahul.
Hi Amala, thanks for this introduction.
Okay, thank you. And how are you?
I'm doing good. How are you?
Yeah, I'm great. Thank you. So, are you ready for today's talk?
Absolutely excited.
Okay, so all the best and take note that you have 25 minutes for the talk and let's start. You can share your screen now. Okay, you can start now.
Hello everyone and judges. Greetings of the day to everyone who will be listening into this talk. Welcome to the second round of Synapse QA Super Voice. As the theme for this round is technology in testing, today I would be talking about a very interesting technical topic that constantly revolves around testing and testers. The title of my talk is Clean Code for Testers. A small introduction about myself. I am Rahul Parwal. I work as a senior software engineer with IFM Engineering in India. Testing is what I find exciting and challenging, and I always look forward to expanding my testing knowledge and horizons. So, before I start talking more about clean code and how to achieve clean code as a tester, I want to take a moment to talk about some statistics about software, software professionals, and software quality. So the omnipresence of software cannot be ignored in today's connected world. The lives that we live are heavily dominated by software. We all use, create, and contribute to the development of software applications consistently through the mobile apps, the laptops, or the desktop apps, and the tablets, and so on. However, the quality of our lives is also deeply impacted by the softwares that assist us in our day to day work, be it the washing machines, the microwave oven, the cars, bikes, cameras, the smart Alexa devices that we use. So, in short, software is rapidly defining or redefining how we engage with the products around us. The growth of this field also conveys something similar. The growth has been tremendous, and today the software industry is one of the largest sector of the world. And as of today, we have 21 million software engineers who are working in this industry. If we talk about the rate of growth of this industry, the industry is doubling in every 5 years. So, which means that anytime somebody completes 5 years in the industry, half of the industry is less experienced than them. And this rate, or the prediction of this rate for the coming years, is also on a very similar lines, which makes us one of the most volatile and fast growing industry of the world. And because of this volatile nature of our software industry, most engineers or most programmers or testers will either work and build on the code or software written by somebody else, or somebody else will work and build upon these things written by them. So, which makes it a pretty interesting field. But amongst all these amazing numbers of growth, something that often gets overlooked or ignored is the losses that we are making due to poor quality, poor software quality, poor code. So, as per statistics, in the US alone, we are making an average loss of $520 billion every year. Although this loss has been declining in the past some years, but still this number is pretty huge. And a lot of amount of money gets waste because of poor quality, poor software, and poor experience that customers face. So, I mean, I'm talking about all these facts around software, the growth, and the losses due to quality. But how does this impact me as a tester? I mean, as a tester, you would ask that we don't directly contribute to the code, and how does all these fact about this volatility and rise of the industry impact me as a tester? So I want to take the attention to the various hats that a tester wears. And a tester is just a umbrella word, but inside their day-to-day role, I mean, they perform a lot of activities, be it an investigator or an executor, be it a reviewer, somebody who executes or explores applications, or somebody who creates test tools and uses programming for that, or designs a script to assist them with testing, and much more. So testers also contribute to coding, and somehow the software testers also need to look into how to improve and make this process more better. And why I'm talking that, because there are some hard hitting facts about our industry too. The first fact is that most automation code bases are bad. They are tightly coupled in nature or non clean in nature. And the problem with that is that bad code often sets bad examples. People come into the team, they see the mess increases with time, and this becomes a very big pile of mess. The next fact, which is very hard, is that most automation code solutions, the frameworks, they start rotting after its creator leaves. So a lot of times, I mean, somebody creates a solution, they implement it, they design some scripts, but once they leave or move out to another team or move out to another role, I mean, maintaining of these code bases or automation solution often become a very typical task. There could be multiple reasons for it. I mean, the code is not good, not understandable, not documented, and so on and so forth. And the third hard fact that I want to focus our attention to is the rise of no code tools. I mean, as we see, I mean, more and more new no code tools are coming in the market. But the important thing to understand is that you will always need coding solutions for your customized needs. You can never use ready-made components to solve your custom problem, your custom issues. So coding is there to stay. Coding is there to be there, and be used as by testers as a tool. So let's understand, I mean, why code rots. Of course, without proper maintenance and care, I mean, everything rots or decays with time. and code is no exception to it. It also rots if you fail to maintain its quality. And let's understand why most code bases rot with time or over the time. So essentially, everybody loves growth, and growth is very a positive word. Everybody likes to achieve it, and most project they actually start with a very clean field start. It's a very clean start where you can work in an organized fashion. There is a good growth possibility, and you can develop different solutions and scripts and utilities, so that you can expand and use more and more automation or more and more code to assist you with testing. But the problem starts when, in the race to go fast, most teams start taking tech debts. So for those who don't understand what a tech debt is, a tech debt is actually a choice of what is easy over what is right. So anytime you choose something easy over what was right and what was to be done, you introduce a tech debt. So essentially, each poor code comes with its own tech debt, and unstructured or unplanned growth often leads to a messy end, which could look like this. So the same place which started in a very clean field, clean state, it could end up being a very messy state, and that makes it very hard for people to understand, people to add on to it, people to build upon it. And maybe the future members who join the team would want to get rid of it or redesign it, recreate it, or probably, even if you want to do that, that again increases the maintenance cost. So I mean if we are in once in a messy state, going back to a good state is very very difficult. And of course, bad code can be cleaned up, as Uncle Bob or Robert Martin says, that bad code can be cleaned up, but it is going to be very very expensive. So instead of going to this path where the coding gets very expensive, the better part, or the better approach, is to start writing clean code. So what is clean code? I've been talking about good code, bad code. So essentially, clean code is a work of art. It's simple in nature, it's written with a great care and thought, and essentially has three major attributes. So the first major attribute of a clean code is that it is elegant in nature. So whenever you see a clean code, you will immediately realize that it is written by somebody who cares about the code or who cares about the solution. Second attribute is that it's efficient, it's well organized, well arranged, well easy to search, easy to understand, comprehend. And the third is it's simple in design, it's simple to read, it's simple to understand. And that's what clean code is. And the beauty with clean code is that once you start implementing or using clean code, with time, with some initial investment into learning the clean code practices and following it, after a specific amount of time, adding new code or maintaining the existing solution becomes very very easy. It becomes very easy to scale, and it even improves the overall productivity in long run. So that's about clean code. Now I'll talk about six strategies how somebody can clean code, or how a tester can start with clean coding, and things that can help them with this journey. uh, of course, there is always a lot of focus on learning different frameworks, different libraries, tools, which is fine, which is part of the game, and which is going to continue to be the part of the game. But what is also important is that we have to learn these basic pillars of our profession, because these are the ones which are going to help us move forward despite any amount of change in the libraries, frameworks, or OS, and so on and so forth. So I'll start with the first point, which is meaningful variable names. So one thing that separates the professionals from amateurs is how they define the variable names. Uh, and professionals often give a lot of attention or a lot of care while defining the names. That they avoid using names that which are like abbreviated, for example, int h or int xyz, int abc, but instead use names which are intent revealing, which reveal the context, which could be searchable later on at some other point of time. And the same thing also applies to the name of the test scripts that you are writing, or the test suite markers that you are using, or the method names that you are creating. So meaningful naming is very important. The second point is meaningful documentation. As they say, any application or any API is as good as its documentation. The same philosophy holds true for test application and test solutions too. Most automation project, if we talk to the creators, they never get extended or collaborated on because of no or very poor documentation. I mean, new people, when they come, they're not able to make sense. How is it going on? And I mean, it's important that we document the context related information, the build steps, or the test selection markers, or the backlog task that we are planning, and what is the design. So I mean, all these things once documented, I mean, they help people or even ourselves to learn better about our solution that we have created and extend it, collaborate on it, or build more upon it. And documentation is just like a letter to yourself to, I mean, write it so that later on when you read it, I mean, you are able to understand it rather than just hinting some small pointers. So the third point is commit messages. I mean, write meaningful commit messages for any solution which is maintained in a source code control system. I mean, commit messages are essentially the audit trail of your coding effort. And it's a common problem that when multiple programmers or engineers, testers, they work on one branch or one repository, I mean, it often gets very difficult to track the code changes if the commit messages are not meaningful or descriptive. I mean, if they don't tell that is somebody adding something for what, or is something getting deleted or commented, and what was the thing, what is the fix that you are doing. If this trail doesn't make it clear, I mean, it gets very difficult to manage and understand what's going on. And essentially, I mean, these minute spending, I mean, these minute details, if you add, uh, it takes few minutes more, but I mean, it essentially goes a very long way in the long term. So I mean, write meaningful commit messages, create a history which others can see and refer and understand, and notice that what you are doing, what you are doing not. Let's go to the next idea, which is assertions. So we all use normal assertions of assert true, assert false, where we give two variables. I mean, one is actual, one is expected. And the problem with these kind of normal assertions is that these are hard to read at times. And I mean, because I mean, once you hover over them, you can see the first parameter is expected, the second is actual. But when somebody reads it at a code level, it's hard to know or instantly figure out that what's going on. So the proposition is that instead use fluent assertions. I mean, assertions can also be made pretty fluent. They can be made pretty easy to read and understand. For example, in the image in the right side of the slide, I mean, you can see that the assertions are written in a way that they sound like a sentence. That test shopping list should contain a specific item, or it should not be null or empty. It should have a count of 10, and which makes it pretty easy to read. And with time, you will also find it very easy to write. Now, if you are wondering, I mean, is such kind of assertion also available in my language in which I code? Yes, I did a basic search and I could find out that such libraries are available in almost all the popular programming languages that testers are using. So instead of random assertions which are hard to read, I mean, use right assertions which are easy to read and, I mean, easy to understand. The next concept is writing meaningful exception handling. One of the very big mistake or very common practice that I see is that uh, uh, programmers put try catch block at each and every method. They try to wrap it with each and every method, but the catch block essentially does nothing. So I mean, there are I mean, each method will have catch blocks, but the catch block has no code. And there is no value in defining try catch like this. I mean, if you're not going to handle the catch, there is no point of putting it. Instead, I mean, use the catch block in a way that provides enough meaning and error information to determine the cause and location of error. You can throw custom error messages and appropriate information that makes it easy for the calling method to understand, or the logs to understand that what's going wrong. Otherwise, you mean, you will be spending a lot of time looking at the status values throughout the code. So avoid that, and send appropriate custom error messages, error codes, instead of just putting try catch and not handling it. So let's go to the last part, which is on the lines of the pattern of automation. But before we talk about it, I'll take an example of this test. This test is a pretty simple test which has two date time classes that are being called, and then some subtraction operation is going on, and then you calculate days, and then the diff is getting compared to a value of 5. And This test will pass if you run it. This test will pass on execution, but uh, when you read it, I mean, it is not very clear. It is somehow difficult to understand that what is the intent, what are we trying to test, what is the case that we are trying to test. So a better way to organize test is to follow the AAA pattern, that is the arrange, act, and assert. So what is the AAA pattern? I'll talk about it. So the first part, that is the arrange, this part talks about all the preconditions that you need for the test, any kind of class initialization, any kind of variable declaration, any kind of dependencies or data that you have to read to make the test. All that part is going to be in the arrange statement. So it's kind of a precondition of your test. The second is act, which is eventually where, I mean, you call the code where on which you want to perform the test. So it's basically the main action of the test is going to perform at the act part, which is the second. And the third and the final part is the assertion, which is kind of the heart of the test, where you check and make sure that everything works as expected, the values come as expected. So this is the third part. So the idea is not to, I mean, develop a practice where you develop where you put comments on each of the section and define arrange, act, assert, but instead logically think and write your code in a way that, I mean, anybody reading it can make sense that what is the arrange, what is the act, what is the assert, and it's easy to follow through, easy to understand, and easy to extend in at the later time. So these were six strategies that I wanted to talk about. Now, I mean, in the end, I also want to talk about some good practices that can help you write more clean code as a tester. So the first part is formatting and indentation. I mean, readability counts. Readability is very important, and beautiful is always better than ugly. The second is having script metadata or adding script metadata. So a lot of times we focus too much on the script methods and the name of the script, but we don't add any contextual information, any metadata related to the script. For example, who was the author of the script, or what was the ALM test ID or the bug ID if the uh, test script is blocked, or the reason for blocking any script or skipping any script. So such type of markers are available in almost all test frameworks, test tools, and you can use them, supply all these metadata information, so that just by looking at the code, it's easy to identify what's going on, what's the context behind it. Next strategy is go dry, avoid wet. I mean, dry stands for don't repeat yourself, and wet is the opposite of dry, which means we enjoy typing. So don't enjoy typing too much. I mean, avoid any code duplication. I mean, instead create modularized method and call them instead of repeating the code bases in multiple places. Next is the scout rule or the boy scout rule, which is on the lines of professionalism. I mean, how somebody can showcase professionalism, and which talks about the philosophy that always leave a place or a coding solution better than how you found it. So suppose you find something unclean when you are working on something, and if you can improve something, do that and leave the place a better, more cleaner place. The next philosophy, very 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 common, that is KISS, which is keep it simple and stupid. So essentially, I mean, write the code as if, I mean, you have to onboard somebody the very next month, and you will have to explain the same code to them. So keep that funda in mind. I mean, don't take biases that I will only have to work on this and I understand what I am doing. I mean, simplify your code. Simplification is always better than complex, and it even helps you learn better about programming and better about what you are doing. So that's KISS. And the last is wrap third party libraries. As testers, we also use a lot of third party libraries, for example, the Selenium, or libraries for API testing, reporting. So it's important that you wrap them up, because if the implementation changes for the libraries, or the method changes, there are some breaking changes that get introduced, then only you have to change your wrapper implementation, and not the each and every script, each and every method. And it's good if you can even remap their exception as required, or manage through them through however you want to do it. So these are some good practices that can help you be better at clean coding as a tester. And as, I mean, Uncle Bob, the author of the popular book on this topic, Clean Code, says that it actually doesn't require an awful lot of skill to write a program that computer stands. I mean, you can very easily write programs that computer can understand and compile and run, but the actual skill of coding is in writing programs that humans understand. And this is something, I mean, that we have to do, and we testers have to do to make test solutions more sustainable, more quality, more good. So I mean, go clean, avoid debts. I mean, tech debts will only leave you with bad codes and will slow you down eventually. So a lot of times people take tech debts because they want to go fast, but trying to go fast or trying to go productive by taking debts will actually make you slow in the long run. So avoid that. That was I mean, all about my presentation. I mean, credits to this amazing book Clean Code by Robert C. Martin, from which I have learned about some clean coding principles, and I'm still learning. I'm still a learner of clean coding. And that's all. I mean, credits to the reviewers of my presentation, Soumya, Sridhar Murthy, and Anandita Rath. They had put a lot of time in reviewing it. So special thanks to them. And thank you for listening into this presentation. And I'm open for the feedback.
Woohoo! That was a nice talk, Rahul. And we always hear about codes and coding, so it's rarely we get a reminder like clean codes. So nicely conveyed. And
Thank
let's
you.
ask our judges now. Okay, we'll start with Julia.
Yeah, hi Rahul. Thank you for your presentation. Overall, I thought you were very knowledgeable in what you were talking about. You really knew your points, so I appreciated that. I liked your slides. They were colorful. There was one point where there was some red kind of clashing on the green, I think you had. So just be careful of how the different colors can appear to different people. A tip that I always have for everyone that I've talked to so far is if you have your Twitter tag, you can put it at the top of each slide or the bottom wherever you want to place it, so that if you're talking about something and I want to share it with other people, I immediately know where I can find you. I'll also, for your overall, it was good. The flow of the presentation was good. You gave me some information and then you got into showing me examples that I could apply. When you were showing the code snippets, I would have liked if you could have told me like what language and what framework was used to create the code snippets. I'm not sure if you told me that and I missed it, but I would have liked that additional information so that I could more, as I look at it, I could immediately tell what it was, so that I can see if it's something that I'm using or if it's something that I may want to try out as well. I think you did a good breakdown of the tool. I like the try catch with the videos of the cricket team catching the ball. I found that to be funny. So I like that. So overall, good job.
Thank
Oh,
you.
and another thing, look at your numbers when you had the 21 million and the billion number. I think the commas were misplaced, at least in how I know numbers are represented. So just double check to ensure that the information that you have on the screen is correct. But good job overall.
Thank you.
Thank you, Julia. And next we have Lena.
Thank you so much, Rahul. You scared me a bit here. Half of the programmers have less than, or half of the people in IT have less than 5 years of experience. That scared me a bit, but I think it was really, really nice that you started the talk with something that really caught my attention. When I was reading the title, Clean Code, and you started with like ethics, it really caught my attention, and I was like, what's going on? And then you segued into that. So it was very, very nice. I loved your energy. I love that you looked alive. You used gestures. You used your voice nicely. Um, I felt there was a big contrast between the intro that was very like big and abstract, and then you went very deep with the code. Um, doesn't have to be bad. It's just it was a very big shift, which some people will love and some people will find it strange. Repeating myself in every feedback, I want more pauses. I think we are, most of us, so scared of silence, but when you're moving from one point to the next, I think it's really nice to have an intentional pause that makes the audience actually take in what you're saying. So don't rush into the next sentence. I'm unsure if you need like you had the six different parts of clean code, and then you went into some different good practices. I'm not sure that part was needed. If you would have removed that, you would have had more time for pauses and breaks and talking slower in the rest. Loved your ending, loved your outro, and I think really nice to hear this topic from someone from the testing side. So very good job.
Thank you. Thanks, Lena. And yes, I'll work on the pauses. I'll work on how to talk better with the intro, and lot to take from for me. Yes.
Okay, thank you, Lena, and thank you, Julia. So it was nice, Rahul. Congratulations. And I really appreciate that you are taking all the feedback in a positive way. And one more thing, I really like the power in your sound. So that is really a plus point. So keep it up. See you in the next round.
Thank you.
Yeah, now it's time for a short break. Before that, let me take this opportunity to give a shout out to our episode partner, Provar. Provar is a complete testing solution engineered for Salesforce applications. See you after the break. Welcome back to Super Voice 2022. Next, I would like to welcome our next contestant onto the stage, Mahathee. Mahathee is a project lead quality at Persistent Systems in India. Welcome, Mahathee.
Hi Amala, how are you doing?
I'm great, thanks. How are you?
I'm good too.
Okay, so are you ready for today's talk?
Yes.
Okay, so let's start. You can start sharing your screen and
Okay.
I'll
One
let you know
second.
when I can see your screen.
Yes.
Yes, I can see.
Yeah, you're able to see?
Yes, yes.
Okay. So should I start?
Yeah, you can start.
Okay. Hello everyone. I'm Mahathee. As a part of the second round's theme technology in testing, I've chosen the topic low code for testers. The motivation behind choosing this topic was in my early years or of my career, I have faced a lot of issues, whether it was related to learning how to program or learning how to code. And I've seen a lot of my team members also having biases to jump into the automation space and start working on coding solutions or taking part in automation testing tasks. So this was the reason I have chosen this topic, low code for testers. So as a part of my topic today, I would be dealing with the above. I would be talking on how this low code for testers has low code terminology evolved, and what are the challenges when it comes to traditional test automation frameworks, and a research of the results that has been conducted by the firm Abstracta with relation to low code or no code tools. And when you are choosing a low code tool for your organization, how do you choose it? Or what are the factors? I will not be going deep diving into this part, but I will essentially give you at least a outlook as to how or what should be considered and the various sources from where you can get to know about these low code tools, because most people will have a blocker as to how can I know about all the no code or low code tools that are in the market. And my experience as to with these tools, what tools I have used or in what way they have helped me, and the closing remarks. So I am Mahathee and I work as a project lead quality with Persistent Systems, and you can find me at the below Twitter handle. And when it comes to low code, beginning with the history of the low code or the no code tools, so in 2014, although Forrester had coined the term low code to simplify the development process, the low code was in existence much before, but it was in the space of application development mostly, and developers had already been using this low code kind of things much before. But and this was basically coined to ease the development part and simplify the process and deliver software at a much faster rate. So this was how Forrester brought it into existence in 2014. And if I had to talk more on how the low code or the no code evolved, I have to take you back deep down into history with the evolution of computers and how the first language and how assembly language was evolved and how programming was complicated at that part of time, and many people could not understand how to code in assembly language and had a lot of nuances with this kind of coding structure. So then there was Fortran that came into picture, and then if you see, then Fortran was only suitable for business or scientific computing, and it had a lot of disadvantages. So not everybody could adapt to it. And similarly, there was COBOL next, which had overcome the disadvantages that Fortran possessed. And then we had the evolution of the web. And so with the evolution of web, there were different systems or different platforms that needed software to be delivered at a much faster pace. And so that's how the no code or the low code solutions basically came into the application development space, and it has also been adopted by the testers now. And the next thing is, although Forrester has coined this term, the low code Gartner has taken this into the masses. And this is, although basically both of them develop or define the term in the same manner, Gartner had taken this in a fashion that many people started to explore what low code is all about, how it will help them in their day-to-day job, and how people could take advantage or use this as a part of their daily work, especially the testers. And if you see, this has been the latest trend in the testing space. More and more companies adopting this low code solutions for their work in the automation space especially, and also testers breaking that bias of not of attempting to go with automation using low code solutions. So this was a brief history about the low code, how the low code had evolved. And next, coming to the challenges of the traditional test automation frameworks. So, before low code had entered into the market, many people, if you had to start automation in your projects, you would typically choose a programming language to code and a framework or a tool which supported your automation work. But these automation frameworks had typically many kind of challenges, and some of them were uh, availability of skilled resources who knew these tools or these programming languages. The learning curve was not so easier, and reusability, one of the most important things when you use frameworks. If you don't have reusability embedded as a part of your frameworks, there's no point in developing a framework. And the most common problem or the nuance being maintenance overheads. In most cases in automation, maintenance has been a major concern, and most teams complain about it. And also scalability. Frameworks have been developed only keeping the current needs in picture, and they don't have an understanding of how the future will change and how to evolve to the changing needs of the applications. So these have been certain problems in the traditional test automation space. So with the use of scriptless automation tools or the low code tools, these challenges or these problems at least have been tackled to some ways. So, whether be it in terms of speed or accuracy, or the return on investment part, or the reusability part, or the maintenance overheads, or the scale, and the most important way these low code tools have taken a role in our lives, at least as testers, is that the learning curve for these tools have become pretty much easier. Everybody nobody, at least in the non-technical people in the team, also have no fear now to learn automation, and at least are going in a courageous manner to try out these tools first without having any kind of preconceived notions. So that's how scriptless or low code tools have solved the challenges in traditional test automation. And then the research results. So Abstracta is a firm that has been run by Federico Toledo, and he has conducted a research on these low code or no code tools based on 4 parameters or 4 columns. So the first thing is the sources. For the source part, he has taken Google as the most common one, because most people search a lot of things on Google, and the search string that he had used or the keywords or synonyms which he had used as a part of this research were low code or scriptless or codeless or no code, because not everybody inputs the same term while searching for different things. And the inclusion and or exclusion criteria is basically the scope, or for what kind of applications he conducted this research on. So he has limited this to test automation, web, and mobile, and not for any kind of a specific platform like SAP or Salesforce or any other cloud-based solutions. And also from these results, he inferred the years that this tool was in the market and the link to these resources. How could people easily access these resources, and what were the features of each of these tools, and how easily they could use this. For features, he considered again the web, mobile, or the API part, and the most control or common one being the version control part, and then the modularization or cross-browser testing, and the visual testing, and the self-healing capabilities. So if somebody wants to see the results, you could see these results. I will be sharing this presentation and the link post the presentation. Then the tools that he had considered for his research as a part of the low code or no code space was these set of tools. And I myself have used certain tools in this. Some of the common ones being Ask UI, Virtuoso, or Test Sigma. So this was a limited scope research. So these were the only tools that he had considered as a part of this research. There were more tools that could have been considered. And also, if you can look here, he had categorized these results as per the platform. So if you can look for the web part, the low code results would be 17.3%, and similarly for the mobile, it's 5.8, relatively a lower adoption rate. And when if you could see the space that has been occupied by both the mobile and web, that is 71.2%, and 5.8% is tools that cannot be classified under any such space. And also, if you see the trends on Google Trends for the low code platforms for the years 2021 to 22, this trend is only to increase, and more people and organizations are embracing this low code for their work or for their application development space, as it's saving on a lot of time, money, and overheads. So the next part I would be talking on is how would you choose a low-code tool when it comes to your organization. Similarly, in the way how you would choose a automation framework or a programming language as per your needs, what are the parameters or what are the factors that are choices to consider when you are choosing a low-code tool? So these were certain things that I would consider when I choose a low-code tool for my organization or for my work in my project. So the first thing being is the community support. So if a tool is newer or relatively new, you would be getting some issues which you need support of people who will help you with solutions, or even if you encounter some programming errors, just as you have Stack Overflow, a community which supports programming related issues. Similarly, you should have a support for the tool that you have chosen, because it will help you sort out your issues at a faster pace. And then the documentation of the tool. The documentation of the tool is very important, as this will help you in a lot of ways to set up the tool with ease and not taking much help from anybody or any person, or not being depending or relying on any person for any kind of issues. And then time in the market. How long has this tool been in the market? Is it new? Is it relatively new? Or is it in the evolving, developing stages, or something like that? So that is one more parameter that you could consider. And also the customer reviews of this tool, not only for low code tools, but usually before buying any kind of a product in our day-to-day life also, we generally check customer reviews. If I had to buy something on Amazon, definitely I would go for a customer review or see what reviews customer. Even one negative review, or a bad comment or a bad remark, I would definitely not prefer that kind of a tool. And also compatibility. Just because low code is easier to use, or easier to start on with your team, you cannot just pick a tool and randomly start telling I will be using this tool for my work or this. You should check your project needs, or what kind of things it supports, and basically you should check the compatibility part and the suitability for your application needs on a day-to-day basis. So these are the 5 factors that I would choose for for considering a low code solution. And also, most people, while choosing a low code tool, think if I can author my test quickly, that's it. It's the end of job, and I'm done and I'm good to start. No, maintenance always has been a very important issue to consider when it comes to test automation or automation frameworks. So you should also be thinking in terms of maintenance overheads, and it's not a single person's work. when the concept of agile came into existence, we collaborate with multiple team members or multiple stakeholders on a day-to-day basis. So with the help of this logo tool, are we able to collaborate seamlessly? Are we able to achieve our work and do it with much ease without any kinds of issues? So these are certain things that you also need to keep in mind. And the other things that you have to look out for is version control. So version control is like you have different, for example, you have your test cases or you have your code on the check on different branches, and you have to navigate to different branches to make some changes. Is this tool supporting? Is this tool having a capability or support for any kind of a version control system? So if there is, you should definitely look out for that. And second, we do not test necessarily only at the UI layers. Automation is not limited to the UI layers, especially, or the functionality of any application, at least as of now, is not definitely limited to UI layer. We also need to consider the API space. So, is this having a support for API, or can we make calls to APIs very easily, or is it supporting our API testing work? This is another aspect to look at. And next, the most common one is the data-driven testing part, and where we run our test cases through different kinds of data, be it from the database or CSV files or the JSON kind of a format. And then whatever tool you have chosen should basically have that reusability in its embedded in it, or else whatever tool you choose will be as good as your existing test automation framework. Next, the support for CI/CD. With faster release cycles and time to market, continuous integration or continuous delivery is also another important aspect to look out. Is your logo tool or whatever tool that you have considered having a support for CI/CD with the latest sets of tools like Azure DevOps or Bamboo or Bitbucket or Circle CI or Jenkins? So is your tool having this kind of a capability? And this is and CI/CD has been the most commonly sought out aspect when it comes to low code tools. And one other aspect is the cross-browser testing. This is the basic and the most simplest. Are you able to run your tests with this tool on different browsers? And does it have support for third-party tools like Browser Stack or Source Labs or Lambda Test? I have included only a few tools, and I've considered these browser for my presentations. So while those were the basic things that you could consider for, it would also be nice to have self-healing locators. When the web application or the application you work on has some amount of changes, do these tools have mechanisms to support robust locator strategy or something like that? And visual testing also has been a very important aspect to look at these days. So does this tool support visual testing in any kind of way? Although Applet tools is there for visual testing, it is good to have a visual testing support. And we focus mostly on building inclusive solutions for our customers or for our clients or for the users who use our product. So does this tool have any kind of accessibility checks in place, and does it have any provision to support two-factor authentication? And email validation is of least preference. I've just included this, that it's a good to have aspect. So certain sources. When I first began my journey with logo tools, I just started off in a hackathon using a random tool without any kind of a knowledge. But after finishing the hackathon, probably I was exploring how do I get an information about different kinds of low-code tools available in the market. Although Google is a source, I was looking for specific sources that would give me information about these kind of low-code tools, or the developments that are taking place or the new features that are being released as a part of these tools. So certain sources that I could find are the product hunt page. This has been really helpful in terms of different tools, and they have their own communities as well. And these are one great source to engage yourself to learn about no code or low code tools. And social media has been the most easiest way to access. If you're on Facebook or if you're on Instagram or WhatsApp on Telegram, there are specific groups targeted to this, and you can easily know about the tool. And they have Instagram pages also give a great deal of information about these low code or no code tools, and you can connect with the people related to these tools, the development part or the marketing executives. And another source that has helped me to an extent is the Ultimate Productivity Toolkit. This is a book that's on Leanpub, if you can check, and this also has some great set of low code or no code tools if you want to just begin your journey with low code. So these are certain sources. And certain examples or my experience with this low code, I consider three tools for this. The first one being AxleQ, because I had started my journey into the low code space with this tool. I was really impressed by the capabilities of this tool. You don't require any prior coding knowledge or prior understanding of the tool. Self-explanatory tutorials and a great community support, and very easily understandable steps in English as to how you can proceed from one step to the other. And the best part about this tool, AxleQ, is the universe that it provides with its linkage to different aspects, and how it's visually representing different tools. And one more tool that has a very promising future, I think, is Test Sigma. This is evolving. I like the test ops part of this tool, and I'm still exploring this tool as this is something that I recently came to know about through a friend of mine. And for the this both these tools support testing at the UI, API, or the mobile layers. And also you can also with AxleQ you can also automate your Salesforce part, and with Test Sigma you can also go for cloud-based solutions and a lot of other aspects. So Postman has been another great tool when it comes to the API space. Although I started using Postman at a later stage, I was very much comfortable with Rest Assured because I come from a programming background. And but when I came to explore this tool, I was amazed with the kind of community support they had, the great collections, the great people. I mean, the resources or the learning curve for this tool is very easy. Anybody can start their journey if they are if they're exploring any kind of a low code tool. They could start with Postman because the kind of documentation or the tool support or the way they resolve issues or the seminars or the webinars, for any tool I have not seen such a kind of a support. And their initiatives have also been great. And you have a lot of programs that are being conducted on a periodical basis for Postman. And there are many things like Supernova. If you want to educate yourself, this is a great program, and there have been many ambassadors to this. So this was my example, my experience with the low code or no code tools when it comes to work. And also I've used certain simple extensions for day-to-day work, like Bug Magnet for the exploratory testing part, or exploratory note-taking extension has been a great one. It gives you a structure and you have to just key in your data. So like this for each, and the Test Case Studio Step Recorder is another great tool. And if you're from a Selenium background, the Selenium IDE or the BOM page object model recorder, that's also a great tool you can explore. If you're wondering from where did I get to know about all this, in my earlier slides, as I had mentioned, Ultimate Productivity Toolkit, that's the place you need to look out for these tools. So I have finally reached the end of my presentation. So I'd like to conclude by saying that although low-code solutions are great for the current context, whenever we choose tools, we should not blindly choose tools. We should choose like testing is contextual or context dependent. Similarly, we should choose our tools also wisely. We cannot just pick a tool because somebody or someone else has used it, and we cannot say this fits in our context and later run into problems. And also, good engineering principles have always been, and they are always to stay. I'm not saying here through my talk that low code is the future of testing or low code will replace testers. I'm just saying that this is an evolving trend in the automation space, and testers can, yeah, lose those biases that they have, and they can easily venture out into the automation space, and they can quickly start learning tools as these have great learning resources and community support. But the primary aspect for a tester will always be important, and that is great thinking skills. So that's what I wanted to convey through my presentation on low-code tools for testers. So I thank Synapse QA for giving me this opportunity to present my topic. I thank the judges for patiently listening to me, and the audience who will be watching this presentation can surely come back and ask me if they have any questions. Thank you, and I'm open to questions and feedback.
Wonderful, Mahathee. Thanks for sharing something valuable because low code and no code are getting trending in the industry, but I think
Yes,
people are misunderstanding and implementing it in the wrong way.
yeah,
So, thank you for this topic. And we can directly ask our judges what they think about your talk.
sure.
Okay, Lena, are you ready for the feedback?
I am. Thank you so much, Mahathee. Let me start with saying I love that you chose low code as a topic because it's something that gets a lot of it gets a lot of heat, a lot of critique. So it was nice to hear a talk that actually talked about the benefits of it. I think you had some great points in the end of what to consider when to go that route and when not to go that route. I think you had a great conclusion slide, and you obviously put a lot of effort into research. I could see that this is a topic you have spent time learning about. I think you tried to put too much content into one session. It made it hard for me to keep up because there was like an avalanche of information coming at me. So I would suggest picking a few of the points that you want to come across and spend more time on each of them.
Yeah,
Uh, and there was a lot of information in the slides. So at some points, I got stuck on reading in the slides instead of listening to your amazing voice, which I should have been focusing on. I was also very impressed that you the flow got disrupted a few times because you got stuck. You couldn't get your slides to move, but you always came back from that, which is like very good job. I was impressed by that. Thank you. And of course, the mandatory more pauses. I love pauses.
okay.
That was great, Lena. Thank you. And we move on to Julia.
Yeah, so I agree with everything that Lena said. So you did a lot of research, and I appreciate that you've done that because it gave me a lot of information that I probably wouldn't have gone out and researched myself because you did the study, you showed all of that information. So you have the information, you have the knowledge. I think areas for improvement is how you have presented that information. So you have all of this information, step back and see how much of that does the audience need to know and how do they need to know it. So create subsections in terms of what you're going to be talking about, which you did with your introductory slide. You gave us like a table of contents, so I knew exactly what you were going to talk about, so I appreciated that. But maybe when you're creating that table of content, use it to determine if you're going to have enough time or if the information is going to be too much or overwhelming. On your slides, you had a lot of information. Like some of your slides could have been split up into like 5 or 6 slides with the wealth of information that was on it, which would have then lengthened your session, but that meant that you needed to take out something. You were in the ending of your talk, you were talking about that you had experience with low code. So maybe if you had came in and had a storytelling about your experiences and the benefits that you gain from it, it would have been just a little bit more interactive, and it wouldn't needed to be sounding like a research. So just think about how you present your information and the flow of your information. I liked that your presentation wasn't specific to one tool. It was more around low code, and therefore I could go and you gave me some tools that I can check out at the end. But I personally would have liked you to add at least a demo so that I could see it working in real
Okay.
time. I think that would have added something really good to the presentation. But
Okay.
yeah, thank you for your time. And I like the topic that you chose.
Thank you, Lena and Julia. I'll surely keep and take all your advices and suggestions into account for the upcoming rounds. Thank you.
Okay, thank you, Julia, and thank you, Lena. All the best, Mahathee. That was great. Keep it up and see you on the next round. And now we move on to our final contestant for today, Suman. Suman is a senior consultant with CGI Canada. He's a career mentor and a public speaker. Welcome, Suman.
Thank you. Thank you, Amala.
Hi, how are you?
Doing good. How are you doing?
I'm great, thank you. So, are you ready for today's talk?
Yes, absolutely ready.
Oh, so that means it well prepared.
Yeah, it sounds like, but yeah, happy to learn from the feedback from judges. I know they are all very well experienced, so would love to get feedback and improvise in a much better manner.
That's great to hear. Thank you.
Yeah,
So, let's start.
sure. Yeah. So should I begin the presentation?
Yes, yes, you can.
Okay, perfect. Hello, judges. Hello, everyone. Today, I'm going to present about the topic microservices contract testing using PACT. So this is the agenda. So first, we will understand about before moving to the microservices architecture, we will quickly touch upon the monolithic architecture. Then we will move on to the microservices architecture, and then how the microservices communicate in a distributed system, followed by what is contract testing, and then what is the importance of contract testing in the microservices agile world. And then we'll touch upon packed flow and packed broker and what is the difference between them. And one quick walkthrough of the pack contract testing. What are the different types of testing and what are the different steps? And finally, the key takeaways during the conclusion. So first, what is monolithic architecture? Now, as you can see in the diagram, it's a very straightforward architecture, and this is the conventional way of uh, building the applications. So this is a complete single unified unit where there is a connection between client, server, and database. So that's how it is connected, and all the functionalities, as we'll be seeing in the upcoming slides as an example, like all the functionalities lie here, and there is a single connection between client, server, and the database. So that's the monolithic architecture. Moving on to what is microservices architecture. Over here now, every service is divided into independent structures, and the client communicates with multiple microservices, and each microservices has its own database and its server, and then which in turn interacts with every client. And also in turn, every microservices connects with other microservice. So that's how in a high level the microservices architecture looks. And this just to summarize what I showed in the previous structure about microservice architecture, that it breaks the application into small independent components, and every component has their own database and own service, and they in turn interact with the client. Now let us look at how the microservices communicate in the distributed systems. So if you see in the monolithic, as we saw here, the user interface. So here the user interface is interacting with the server, as we saw at the start that in the monolithic architecture, the client is connected with server and then the database. So there is a single connection and it forms like a single entity. So over here, if you can see in the server repository, all the functionalities like user profile, order, products, all these are lying in a single project code, and the user is directly interacting with the server. So for example, if let's say a user wants to get the details of the orders, all the code lies in the same project, and that's why we can call them methods. Like if we want to get the orders, we will be calling the get orders method by passing on the user ID, and all the details will be coming back as an output to the for that user ID. So that's how the monolithic architecture works. Now, if we want to understand the microservices communication in the distributed system, so this is how it looks like. So the user connects with the user profile. Now, if you see here, like all the functionalities was lying in the single server repository. But over here, if you see that every functionality is subdivided. Like the orders is having its own database, the payments is having its own database, and so on. So now if we go back to the same scenario where the user needs the details of all the orders are there, we cannot call the method directly because these two are separate projects. So in that case, what will happen is there is an API connection that will be required, and that's how we'll be communicating. If you see here, there are multiple projects and there are different functionalities like orders, payments, and everything. All the functionalities are subdivided. And we are using the APIs to connect between multiple services. So over here, as we saw, they are in different functionalities. So we cannot directly call the methods. These are all separate projects. So we need API connections to we have to use APIs to communicate between the multiple services. And these are mainly REST calls. Now there are different ways to call as well, but majorly it's all REST calls which are used to communicate between the microservices over here. And then this is done through then like orders and then user ID, and this is all about API, the way they are called. So that's how the communication works. If we have to take one example where we are looking for Amazon orders, so what will happen is we are sending the request to those URL where the microservices hosts. In this case, it is in amazon.com. And then if we put the orders, then all the order over here, like the call goes to the orders, and then all the response comes back as a JSON request. And then the user profile microservice will interpret that JSON, and then they will derive all details. So microservices architecture is much more complex if we see as compared to the monolithic structure. Next, let's understand what is contract testing. Before understanding contract testing, let us quickly touch upon integration testing, and then we will understand what are the disadvantages of integration testing and then why contract testing makes much more sense. So over here, there are three different services: order service, product service, and consumer service. And they all are interacting with each other. So if the product requests the order service, then it will go and give us the status code 200 if everything looks okay. And all the requested details will be passed on as a JSON response. Similar communication will happen between order service and the consumer service. And every service connections, we need the integration testing. Now, the main concern with integration testing is that we need the actual services to be present, and there is the dependency on the actual services because we need the details in real time. So it is hitting one service is hitting the other service in real time. So there is dependency on the actual service. So these are some of the advantages and disadvantages of integration testing. Integration testing, as we all know, is more of checking all the end-to-end integration. So the advantage is that we can check the end-to-end flow in a much more better, robust manner, and it gives confidence to make sure that we are delivering a quality product in the production. But at the same time, as we saw, that it is introducing dependencies on the actual services, and there are high chances that it will break or it will need a lot of maintenance. And because of the real dependency and lot of integrations are there, the time to respond is also slow. And now we know in agile world we need like fast time to market. So these are the challenges with the integration testing. Now, in contract testing, what is happening is it is the validation of contract between the consumer and provider. So the same concept is there. But now here the difference is there that we are not depending on actual service at the provider side, and the validation is done in the form of a document which is known as a contract. So contract is nothing but the document which is generated, which will have all the expected results and the expected response, and then the validation happens, and then the validation is happening based on the contract that is generated. So there is not actual dependency of the presence of the actual services. This is one example of the contract testing where the product service, which is one form of a consumer service, it is doing the same testing of request and response with the help of a mock provider. So after the unit testing is done with the provider, the contract is generated. So a contract will only be generated when all the checks are passed, and then the provider side order service, it is validating the response based on what are the expected outputs of the contract. So this is how the contract testing flow works. Now, what is the importance of contract testing in the microservices agile world? Now, as we discussed, that contract testing is mainly validating the communication between multiple services through API connection. One of the example can be checking the connection between the web front end UI and the client API. So in that case, as we saw, that integration test depends on the actual services, and that's why there are a lot of disadvantages and dependencies in terms of the actual services, and it is very slow and expensive. So that's why contract testing plays a key role in the agile world. These are some of the advantages of the contract testing. So if you see that all the disadvantages of the integration testing, they are being handled and it is providing as an advantages. It's more stable, it is more independent because there is no dependency on the actual services. It is easier to maintain and there is a better version control. So what it means is we have the provision to compare the previous versions with the current version and make sure that everything looks good as part of the contract testing. Now let us look at what is PACT broker and PACT flow and what is the difference between these two. So PACT broker is an application which is helping in the contract testing by making sure that we can share the contract. So as we saw in the contract testing, that it is depending on the contracts that are generated by the consumer, and then the provider is validating the response and the request based on the expected request and response details which are present in the contract. So PACT broker is helping in sharing the consumer driven contracts and also the verification results. And we will go through one example where I'll be showcasing how the output looks in the PACT broker. So it will be much more clear in the upcoming slides. And it is optimized for using with PACT contracts. And at the same time, it can also handle other type of contracts that can be serialized to JSON. Now, as we all know, and as we all saw in the previous slides about the disadvantages in integration testing and how contract testing is helping us test microservices in a better way. One downside is that in integration testing, all the information, because it's all about checking together. So all the versioning and all the status, whether it's passed or failed, everything in the integration testing lies in the single component, single place. But in the contract testing, because it's checking multiple stuffs, so all the details are spread across different forms of builds. So what pact broker is doing is it's forming as a collation tool which will bring all the information together, and it will make sure that we are making an informed decision in order for us to go live and deploy the product. So it will have all the version numbers, test status, and everything at one place, and then we will be able to decide whether it's a go or a no go for production deployment. So that is the role of pact broker. And this is one of the example of how the pact broker output looks like. So we will have the consumer version number. We will have, so for every pact interaction between the consumer and provider, we will have the version number, and also we will have the green status or the red status based on the pass or fail. So that is what the role of pact broker in one of the role of pact broker in the contract testing world. Summarize, the pack broker allows us to integrate and automate contract testing in the CI/CD pipeline, and it ensures that we're able to deploy the products much more quickly in the agile microservices agile world. And it also generates, as we saw in the previous example, that it is helping us generate the versioning in a very automatic manner. And we are also able to see the visualize the network diagrams of between services. So this is one of the example of the network diagram which is generated from the pack broker, where it will tell which are how many services are there and how the services are interconnected to each other. As we saw in the microservices architecture diagram, that there are multiple services and they are connected with each other. So this is more of a visual representation of all the different services and how they are connected and how everything is there. So this is one of the network diagram example which is generated from the pack broker. Now we saw what is pack broker. What is packed flow in that case? So pack broker is an open service tool, but which helps in the contract testing. But in this case, we have to do everything on our own. So we have to deploy, administrator, and host everything we have to do on our own. So pack flow is one step ahead of the pack broker, which is more of a plug and play option. So what it means is that you can deploy and everything do on its own, and it is much more convenient option with all the features that are available as part of the plug and play option. And it has much better features as compared to the pack broker. So pack flow is a fork of the open source pack broker. What it means is it's a copy of the same repository with much additional features. So everything is same. It's a complete copy, and that's why it is mentioned here. It's a fork of the open source software pack broker, but at the same time, it has got much additional features. So it has the better user interface. There is a option of field level verification. There it's much more secure, and there is an option of more authentication and user management. And it has a fully technical support team which is there to solve your issues and queries, which is not available with the pack broker. So to summarize, pack broker supports the contract testing by giving the version number, the status of pass and fail all in one place. And packed flow is a same copy of the pack broker, but it has additional features as compared to the pack broker, and it has a much better issue and query resolution system which is taken care by the subject matter experts. Now let us look at the integration and strategies to implement contract testing using the pack flow. So here we will go what are the main steps and what are the different types of tests and some of the examples of code snippets to understand the flow of how we are doing contract testing using the pack tool. So before that, just to summarize, like PACT is a, or as we saw that it's a consumer-driven contract testing tool, which is helping in performing the contract testing. Contract is nothing but, as we saw, it's a document which will having the expected response and request, and the provider is validating the request and response based on the details provided in the contract. It's an open source tool and it is which is available in several different languages, and it is used for testing HTTP and integrations that are used for contract test. Now, what is meant by consumer driven? As we all know that consumer driven means that consumer is at the heart. So we are only requesting and testing and validating the pieces which are requested by the consumer side. So even though there are a lot of details present, but we will only validate and send the things that are requested by the consumer. And that's why it's known as consumer driven. Now, these are the 7 tools that integrate with PACT, out of which JavaScript, Python, PHP, and Ruby are some of the most popular tools that integrate with PACT. So in PACT for contract testing, there are two major components of testing. One is the consumer side of testing. So first we will look at the consumer side of testing, and then we will look at the provider side of testing. So in the consumer side of testing, we will first set up the consumer test. So what we will do is we will mock the provider using PACT. Then we will set up the expected result and the response which is being expected, and that is known as an interaction. Then we send the actual request to the mock provider, and then all the verification happens based on the expected result which is there in the contract. Now a contract, like the contract in the consumer side, only gets generated if all the checks are passing. So that is the main criteria. And if the verification fails, then the contract is not generated. So let us look at step by step with a sample code example. So this is the first step in the thing. So if you see, this is where we are talking about mock the provider using PACT. So the first step is we are setting the mock provider utilizing the PACT tool, where over here we are setting up the consumer name, provider name, which port will be run on the mock provider. And also we are defining here where we are storing the PACT log and where the contract is there. So this is a definition and the setting up of the mock provider. So this is the first step in the consumer side of testing. Next, we are setting up the interaction, where as we saw that we are defining what is the expected result request going to be, and then followed by expected response. So interaction is the request that we are sending to the mock provider. So if you see here, first we will set up, like in this example, the method name is the post, and which is going for the test path. So this is the expected request that we are setting up. Similarly, we will set up the expected response, like we are expecting the status code 200, we are expecting the content type of JSON, and then over here we will define like what are the parameters that we are expecting. So this is the common structure of how the interaction looks like. Next, we will actually send the request to the mock provider, so which defines like this is the actual test body and what are the responses that we are expecting. So this is the actual request which is going to the mock provider. And then once the request is given, first we will run the verifications, and then as we saw earlier that if all the check passes, then only the contract will be generated, and if it fails, then no contract will be generated. And once that contract is generated, we will upload that in the PACT broker, and it will store all the contracts across all the services. So that's the consumer side of testing. Now coming to the final part, and the other half of contract testing is the provider testing. So here it's much more simpler, where we are setting up the provider name, the base URL, and then the PACT broker URL. And once the verification is run, we will provide the output. So this is the first place where we are setting up the provider name, the base URL, the packed brewer. So again, it's all setting up the details, and then we are triggering the running of the verification so that it passes, and we are passing all the above options to it as a parameter. So if you see here, the options are being passed, all the parameters are passed, and then the verification is run. And then once the whatever is the output, as we saw earlier in from the pack broker, this is the validation coming up. So it tells what is the consumer provider, the contract is run, and then over here the status of pass or fail is generated. So the verification output is published. Now coming to the final conclusion and the key takeaways. So what did we discuss so far? Let's summarize. So we saw first that we understood that the monolithic architecture is a single unified unit where the client, the server, and the database are connected, and the server is having all the functionalities together. Then we saw about the microservices architecture where the client is interacting with multiple microservices, and every microservices has their database and the server, and they can run independently. Then we saw the microservices communication in the distributed world, where we understood where in the monolithic architecture, there are single project and they cover all the functionalities. Whereas in microservices, we are using APIs to communicate between multiple microservices, and these are majorly REST calls that are happening between the microservices. Then we saw what is integration testing, and there is a huge dependency on the actual services, and that's why it breaks easily and it needs a lot of maintenance. And then why contract testing is preferable, because it's more fast, reliable, easy to maintain. So it takes care of all the disadvantages that is there as part of integration testing. Then we saw the difference between the packed broker versus packed flow. So packed broker is mainly additional support for contract testing, where it will combine all the version numbers, pass, status, fail, and it will bring together in one place, and it will publish the result for contract testing. And packed flow is the open fork of the open source packed broker, which will have much more advanced features as compared to UI, authentication, etc. Then we saw one example of flow of PACT, where we saw that it has the consumer side of testing and the provider side of testing. We went through the flow and we saw that there are 7 tools that integrate with PACT, out of which JavaScript, Python, PHP, and Ruby are the most popular integration. So that's it from my side. These are some of the sources and references where you can go and go see about this topic much more in depth. And I thank the judges and the audience for giving me chance to provide my insights on this topic. That's it from my side. Thank you so much.
That was a good attempt, Suman. You
Thank you so
narrated
much.
the technical. Sorry, oh, sorry.
No, I was saying thank you so much.
Okay. You narrated the technical aspects in a very nice way, and it is sure that you prepared well because you finished on time.
Yeah, yeah, a little bit of preparation, but I'm pretty sure, there is more scope, and I'm excited to learn to judges to see what is the feedback from their side to note down and
Oh,
improve.
okay, that was awesome. So let's ask
Thank you
Julia.
so much. Hi, Julia.
Hi, Suman. Thank you for
Hi,
sharing. Overall, I
thank
think you did a really great job. You had great elements of a talk. You had
you.
good slides. You introduced us to what exactly you're going to talk about. You had an agenda that you followed. You stuck to the time. So I was able to frame my mind around what I was going to be hearing about today with your agenda. And then you went through all of those things really well. And then you did a really good
Right,
conclusion where you summarized everything. So it reframed my mind into, okay, this is the relevance of the information that you just provided to me. I liked that you
right,
showed demos, like code snippets from the tool, so that I have an idea of how it actually
right,
works. I like that you
right,
progressed me throughout the concepts. So you talked to me about what are microservices first, what's contract testing, and then you got into the tool. So I really liked that your presentation overall matched back to the topic that you had. I learned a lot of information from your presentation, so thank you for that. Some other things that you can improve. Oh, and also your
Yeah.
flow was really nice. So you weren't going overly fast where it was hard for me to keep up. Some of the things to improve
Right.
on are just the designs of your slide where you had a lot of words sometimes. So I was reading from your
Okay.
slide instead of listening to you. So some of the things,
Right.
just find a better balance
Okay.
between having images where instead of the words, so images that, and then you use the words that like your speaker notes. You're still speaking on it, you're still giving us the information, but I'm not reading from the slide and not really paying as much attention to you. um i think
Got it.
I think that was really the main thing at the end. If you could have a slide just to say these are the ways in which we can connect with you, because I think you gave a lot of good information. So if I was able to just
Right.
remember where I can tag you if I'm talking about your talk, just to that's something that you can also add as well. And just in the overall design
Sure.
of your slides, just try to be just a little bit more creative with the many words on the slides.
I'll do that, Julian. Thank you so much. I've noted down the two improvement areas, and
Mhm.
in the next round, I'll definitely implement that. But thank you, Julian.
Thanks for your time.
Thanks,
Yeah.
Julia. And now we move on to Lena.
Hi,
Thank you
Lena.
so much for. I learned so much. I was really worried in the middle that you would run out of time because I really wanted you to be able to fit everything in, but you were like spot on with the time. You were very calm. You were very clear. You used your voice and gestures in a really good way, and you did a great job with pauses. So thank you for that.
Thank
You
you.
didn't have to ask for more pauses. I also had to kind of reframe my mind because I realized when I was listening that there are many different types of talks. There are like inspirational talks or storytelling talks and overall generic talks. And then, of course, there's also talks that aim to teach you a topic. And that's where I felt like
Right.
this was a talk that tried to teach me something. I think you might struggle with that format if you're on like a big stage in front of a big audience
Right.
because they won't be able to read everything from your slides.
Right.
But it worked amazing in this setting where I could listen to you and also read from the slides. So
Right.
if that's what you're aiming for, then I think it was perfectly fine. But if you are aiming for a different kind of talk, I agree with Julia. There's way too much information on your slides in that case. I was also very impressed that
Right.
you managed to do like technical abstractions in a slide. So my challenge,
Yeah.
taking it to even the next level, would be thinking, how could I make this even more abstract?
Okay.
Love that you did a summary before you moved on. I love that you walked us through the key takeaways in the end, and I really well done.
Yeah. Thank
Okay,
you.
thank
Thank you
you.
for the valuable feedback, Lena.
Thank you, judges. So, all the best, Suman. Congratulations. And yeah,
Thank you so much.
I definitely think this is going to be a good reference for many because this is have a tutorial quality. So, waiting
Thank
for
you.
your next Power Pact presentation on the next round.
Sure. And of course, with all the valuable insights from judges, I'm sure I'll be able to implement and improvise more in the coming round as well. So thank you so much once again, judges, for your valuable feedback. It was really helpful.
Okay. Okay, cool. See you on next round. Bye. Okay, so thank you, judges and contestants. With this episode, we wind up knockouts round. So, in the next episode, we start a new round called playoffs on the theme process, approach, and leadership in testing. Audience, please vote for your favorite contestant and leave some feedback for them in the links provided in the comment section. And once again, thanks to our episode partner, Provar. If your actions inspire others to dream more, learn more, do more, and become more, you are a leader. Till we meet again, this is Amala signing off. Bye.